Hello, in this video I'm going to go through and answer two questions. What I really want to stress with this video is that these questions are actually the same, just in the question on the left here we're looking at circles, and the question on the right here we're looking at lines. So this question, this video is the response to a student asking about the equation of a circle and finding points on the circle. So let's take a read of these. A circle has a center at 0, 0 and contains the point 5, 12. Complete the following. We want to find the equation of the circle, find if the point 3, 4 is on the circle, and we want to find another point on the circle. So one thing that I always like to do before I start is to draw a picture. So we're just going to go in here. Right, so here's our Cartesian plane. And so I'm going to have the point 0, 0, and if I'm going to go 5 across and up 12, so that's a point here. So the idea is that the circle is going to look something like, that's not a very good circle, something like this. Okay. Now again, this is not a lovely diagram, but what I want to get at is the idea that it's good to draw pictures. Pictures are useful. So we see that this is the radius there. So I know that the equation of a circle is r squared equals x minus a squared plus y minus b squared. And where r is the radius and the center is AB. So let's just pause for a second. Now let's go back to this side. So in this question on the right is a line has a slope of 3, contains the point 3, 4, and we want to find the equation of the line. So we know the general formula for the equation of a line is y equals mx plus b, where m is equal to the slope and b is the y-intercept. So with this question, students will often say, well, right away, okay, well, the slope is equal to 3, and I don't know the y-intercept, but I know it contains the point, and let's call this point P, 3, 4. So all I have to do to find this is say y equals 3x plus b, and then I'm going to substitute the point 3, 4 into there. So 4 equals 3 times 3 plus b, so we get 4 equals 9 plus b, so b is equal to minus 5. And now, again, like with the last question, it might have been useful to draw a little sketch here. And the sketch just gives me an idea if I'm right. So I go 3, 4. So this is the point 3, 4. And then I see that the slope's going to be something like this. Because it's it's positive, so it's going to be in that direction. So I feel good that my b value is negative. Again, it's not going to tell me if I'm right, it'll tell me if I'm possibly wrong. So now we've done this question, let's come back over here. So remember I said these questions are essentially the same question. I know the center of the circle is 0, 0, so therefore I can say r squared is equal to x minus 0 squared plus y minus 0 squared. So we can say r squared is equal to x squared plus y squared. And a lot of students will first learn the equation of a circle with center 0, 0 as this. So we need to find the radius. And like I said, over here we need to find b. So we substitute in the point. Well, we know the point 5, 12 is on the circle, so I can just substitute it in. So r squared is equal to 5 squared plus 12 squared, which is equal to 25, plus 144, which is equal to 169. So therefore r is equal to plus minus the square root of 169, and r is equal to 13. Now you'll notice here I've left out the minus 13, and that's because radiuses are always positive. So therefore the equation of this circle is 13 squared is equal to x squared plus y squared. And students often ask, do I need to write this as 169? I leave it as 13 squared. And I recommend leaving it as 13 squared because then you know right away what the radius is. So I really want to make the connection that these are the same type of question. Here I'm working with a circle. Here I'm working with a line. Alright, let's do part 2 now. We'll do part 2 in green. So if we want to find the point, let's go to this one first. If we want to state if the point 1, 2 is on the line, well, if the equation of my line, actually, let's just write this. The equation of my line is y equals to 3x minus 5. And let's just circle these or box them in. So if I want to show if 1, 2 is on this line, all I do is I sub in the point 1, 2. So therefore, 2 is equal to 3 times 1 minus 5. So 2 is equal to 3 minus 5. So 2 is equal to minus 2. Well, we all know that this is actually incorrect. 2 is in fact not equal to minus 2. So this is invalid. So since left side is not equal to right side, the point 1, 2 is not on the line. So for this question, if we wanted to state if the point 1, 2 is on the line, we simply substitute it in and see that the left side is equal to the right side. Well, it's the same thing over here. We want to see if the point 3, 4 is on the circle. Now, we can say with I think a good degree of confidence that 3, 4 isn't on this circle, but let's just show how we do this algebraically. So we're going to sub the point 3, 4 in. So therefore we have 13 squared is equal to 3 squared plus 4 squared. 13 squared is equal to 25. And this is not true. So since left side is not equal to right side, the point 3, 4 is not on circle. Okay, let's scroll down a bit. Let's do part 3. So part 3 says we want to find another point on the circle and find another point on the line. So let's do this one in black. So for part C, well, if our equation of our line is y equals 3x minus 5, I can plug in any x value that I want. So if I want to find another point, all I have to do is pick an x and sub in. So let's say x is equal to 1. So y is equal to 3 times 1 minus 5, which is equal to 3 minus 5, which is equal to minus 2. So therefore, the line contains the point 1 minus 2. So all I have to do if I want to find a point on this line is just sub in a value of x. And what's nice here is that any value will do. Because a line, there's no value of x that I can give you that you can't solve for y if you sub it in. So now let's take a look at the circle. So the circle, we have 13 squared is equal to x squared plus y squared. Now, one thing that I've done with my class this year is, in grade 11 you learn about something called the domain and range. And one thing we started getting the habit right away is writing down what's called the domain for this relationship. Now, a domain you can think of as the x values that make sense. So if the center here is at 0, 0, and I move a distance of 13 to the left, that means this point is going to be negative 13, 0. And if I move 13 to the right, this point is going to be 13, 0. So the values that make sense for this circle go from negative 13 to 13. So some students will write negative 13 is less than or equal to x, which is less than or equal to 13. So we want to pick another point that's on the circle. What this means is that if I'm going to find another point on this circle, let's draw this in red, I have to pick an x between negative 13 and 13. So let's pick one. Let's pick. So let's say let x equal to, say, let's say negative 5, just for fun. So all I do is, just like with my linear example, I substitute in. The difference here, there's a couple differences, but nothing too significant. The differences here are, first off, y is an isolated force, so I have to do a little algebra and rearrange. Also, if I take a look at my picture I've drawn, I'll see that there's actually negative 5s around here. There's actually going to be two answers. So these are both answers. With a little bit of thinking, you probably can get the answer without any actual algebra here, but let's make sure we understand the algebra. Well, 13 squared is 169, negative 5 squared is 25, plus y squared. So then I'm going to get y squared by itself, so 144 equals y squared. So let's write it, y squared equals 144. And this is the point I really want you to watch. When you have to take the square root, you always have to account for both the plus and the minus case. So therefore y is equal to plus or minus 12. So two other points on this circle are negative 5, 12, and negative 5, negative 12. And if we scroll up here, we can see where these are. This would be negative 5, 12, and this would be negative 5, negative 12. Now, let's do a little side idea here. So remember how I said you substitute into any value of x to the linear equation because anything I sub into here was going to work. Well, with a circle, there's only select x values that make sense. So if there's only select x values that make sense, I might pick the wrong ones. So let's see what happens. So let's say I picked for whatever reason x equals 14, and we can see that x equals 14 is obviously not on this circle. X equals 14 is over here somewhere. So let's see what the algebra does. So we get 13 squared is equal to 14 squared plus y squared. 169 is equal to 196 plus y squared. Is that neat? 13 squared is 169, 14 squared is 196. Fun little algebra. A little bit of interesting stuff there. So then if I do a little bit of rearranging here, we get 169 minus 196. And we get negative 27 equals y squared. So y is equal to the square root of negative 27. And if you get your calculator out and you try and sub this in, you're going to get an error. And so what happens here is, if our algebra ends up with the square root of a negative, this means that there is no answer. And this is what your textbook will tell you. Now you'll notice I've left a little space here. And actually I need a little bit more space here. Because often people will say there's no answer. And I want to point out here that it's not that there's no answer, it's that there's no real answer. And this, for our purposes, isn't that important a distinction, but I do recommend that I have to remember my plus or minus here. Pardon me, plus or minus. That get in the habit now of saying there's no real answer, because you actually can take the square root of a negative, but that gets into complex numbers. So just to sum up, this question is in response to a student's question about finding the equation of a circle and checking if they're finding points on the circle. And what I always want to stress is that whether you're working with a circle or a line, it's the same concept. And remember, always come back to what do I need to substitute in and what do I need to find. I hope the video helped.